Mhm.
Namaste सर्वेभ्यः कृपया वीडियो ऑन कुर्वन्तु if possible. Namaste Maitreyi Bhagini.
नमः सर्वेभ्यः।
So while we are waiting, if you guys could fill out this survey, I'll send it out later as well. But just to get an idea of who all are attending, would be good for us to cater these sessions better. So I'm going to send this one form in the chat, and we'll start at the 105 mark.
Which one do you think is going to taste better?
All right. So, namaste sarvebhyah. Mama nama Naisargi. Dallas Raje Vasami. Dhye mantram vadami. Om. Pathami Samskritam Nityam. Vadami Samskritam Sada. Dhyayami Samskritam Samyak. Vande Samskritamataram. So thank you all for joining to our fourth SNYP Melanam. Last time in December, we had Siddharth Mahodaya lead the first part of this. So Siddharth Kaki Mahodaya, he is currently a navigation discipline engineer at NASA in Houston. He did his PhD in aerospace engineering. And the first part of this session, he talked about kind of the philosophy behind Jyotiṣaśāstra. And in this session, which is part two, he'll do kind of an exploration of the underlying astronomy and timekeeping methodologies of Jyotiṣa. And we really appreciate him taking out the time and curating this presentation for us. I do want to let you know this is kind of an interactive session, so feel free to raise your hand in between if you have questions for him. He has set up ways for him to demonstrate some of the topics that he'll talk about today. So if you feel like you would like to know more about it, he can definitely go in depth on those. And then after his slides, there will be a moment for everyone to kind of have a discussion, so you can have your questions ready for then as well if they're really in depth. In the chat, I'm going to put this form once again. This is just for Yuvagana to get an idea of who all are joining these sessions. So just to take like maybe a couple of basic data points about who you are, where you are coming from, so that we can curate these sessions better to our audience. And with that, Mahodaya, I'll transfer it to you.
Agajanana Padmarkam Gajananam Aharnisham Anekadantam Bhaktanam Ekadantam Upasmahe Sharada Sharadam Bhojavadana Vadanam Bhuje Sarvada Sarvada Smakam Sannidhim Kriyat Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavatpada Shankaram Loka Shankaram Namah Savitre Jagadeka Chakshushe Jagat Prasuti Sthiti Nashahetave Trayimayaya Trigunatma Dharine Virinchi Narayana Shankaratmane Namah Sarvebhyaha Adya Rathasaptami Shubhatitau Ravivasare api Suryadevasya Shubhadine Vayam Jyotiṣaśastrartham Vaktum Punarmilamaha. On this auspicious day of Ratha Saptami, which coincides with a Sunday, we meet again today to discuss further on the topic of Jyotiṣaśastra. Last time we had spoken, we had talked a little bit about the philosophy, the underlying philosophy of the Shastra. And today we will talk a little bit more about the very basics of the astronomy and timekeeping methodologies that underline it. So like Naisargi Bhagini has said, this should be an interactive session. So if any time you have questions or want clarifications, please do raise your hand or put it in the chat. And so we will start the presentation. So Jyotiṣa, why the astronomy of the ancient past is still relevant today. So last time, a quick recap, we had talked about the purpose of Jyotiṣa. Why was it even developed in the first place? It is a Vedāṅga. And its purpose is to let us know when and where to perform an action. We talked about how time and location are always specified with respect to celestial bodies and their motions. For example, if you want to talk about a position on Earth, you'll give a latitude, longitude, and an altitude, for example. The years that we measure are measured by the Earth's revolution around the sun. The months by the moon's revolution around the Earth. The day by Earth's rotation about its axis. So time and location always with respect to celestial bodies and their motions. Therefore, the best time and the best place to perform an action is also a function of celestial bodies and their motions. We had talked about how certain times and locations are more conducive for certain actions. For example, studying is more conducive in a quiet library, right? And so when and where you perform something is dependent on when, the result is dependent on when and where you perform something, then the best time and the best place is also therefore a function of time, and time is a function of the celestial bodies and their motions. And so this is why Jyotiṣa as a Shastra was developed. We looked at one of the Vakyas from the original text of Jyotiṣa, which is called Vedāṅga Jyotiṣa by the Maharshi Lagadha. And in it, Lagadha Maharshi very clearly refers to Jyotiṣa as Kala Vidhana Shastram, the science of the methodology of timekeeping. He also refers to as Ganitam, that which is computed. Therefore, this hints to us that there is a science and a method behind Jyotiṣa. We had also discussed that Jyotiṣa, as we know today, is called Triskandha. There are three branches, three limbs to it. And the foundation of it is called Siddhanta, which talks about the astronomy and the mathematics, the scientific basis for it. And then there is Samhita and Hora, which today most people, when they hear the word Jyotiṣa, they think about these, which are the predictive aspects. But all of this is built on the foundation of Siddhanta, which is astronomy and timekeeping. So we had talked about the philosophical aspects of Hora last time. So today we will go into just the very basics, because this is a very, very deep Shastra, just the very basics of some of the astronomy and mathematics that we will generally come across on a daily basis. So there are several units of time that we will see, and here are just a few of them. This is by no means an exhaustive list. Some on the left-hand side are smaller units of time, on the right are larger units of time that we will come across. For example, the solar day, Ahoratra, is a common term given. Ahaha means the day and ratra, ratri is night. So ahoratram is the full day and night cycle. You'll see that broken up into muhurtas, which is something that we're all familiar with. 30 muhurtas in one solar day. That is the Jyotiṣa equivalent of the hour, right? In the Western system, we have 24 hours in 1 solar day. In Jyotiṣa, in our system, it is 30 muhurtas in 1 day. Therefore, there are 48 minutes. So it's like an hour instead of 60 minutes is 48 minutes. So that's really where that comes from. And then each muhurta has 2 gatis to it, and so on and so forth. One unit that we usually take to mean the minute, it actually technically has a different meaning. Nimesha or nimisha, we usually refer to in colloquial language that, it's just a minute, just wait 1 minute. Eka nimishaha, for example, right? In reality, it is a much shorter time period. And for example, this is something, the way that it's described in Śāstra is the time it takes you to blink your eye, for example. And this we'll see in many other cases. For those that recite the Lalita Sahasranama, you'll notice this. Unmesha nimishotpanna vipanna bhuvanavalihi. When Amba, when she opens her eyes, Unmesha, it's Utpanna of the Bhuvanavali. All the lokas get created. Srishti happens when Amba opens her eyes. And then Nimesha, when she closes her eyes, it's Vipanna. It is the laya of all the bhuvanas. And so that's where the word Nimesha comes from, or Nimisha comes from. And then there's also all the larger time units that we will see. We have the Deva, the timekeeping of the Deva. So in Svargalo Devaloka, 1 day for them is 360 years here on Earth. And so on and so forth. You see the Kali Yuga, and then Dvapara, Treta, Satya Yuga, and then Chatur Yuga cycle. Then we talk about Kalpas, and then there's Manvantaras, and all the way up to the day of Brahma. And then Brahma cycle is the year Brahma, then Brahma cycle is 100 years of that. So very, very small time units, all the way down to the Triti that you see on the left-hand side, to very, very large time units that Jyotiṣa talks about. So the very basic thing that we're all usually familiar with, that we interact with, is the Panchanga, the 5 limbs, or the 5 aspects of the things that we usually talk about. And so the 5 angas here are 1, the Tithi, the Vasara or the Vara, Nakshatra, Yoga, and Karana. So whenever you go to like my Panchang or Tripachang or whatever Panchang that you use, these are the 5 main things that we will see. There's more, but these are the 5 main things that come about. So what exactly are these? So Tithi is the lunar quote-unquote day. And the way that it's measured is the following. We all know that the Earth revolves around the sun and the moon revolves around the Earth, right? If you were to draw a line from the Earth, look towards the sun, and then draw another line from the Earth towards the moon, you have 2 lines, and there's an angle between these 2 lines. As Earth is revolving around the sun and the moon is revolving around the Earth, the angle between these 2 lines changes. When that angle increases by 12 degrees, that is when we say it's changed from one tithi to the next tithi. It is measurement of what is called the elongation angle of the moon with respect to the Earth and the sun. And so it is 12 degrees increments, and there are 30 tithis total. There's Amavasya, the new moon day, which is when it starts. There's 14 tithis for what's called Shukla Paksha, which is the waxing period or the waxing fortnight of the moon. There's Purnima, the full moon, and there's the Krishna Paksha or the waning period of the moon, and then repeat with Amavasya. So you have 30 tithis, each one being 12 degrees. 30 times 12 is 360. So you have a full cycle covered right there. So that is 1 lunar month. And so some of these diagrams here will hopefully explain what that is. So for example, Amavasya will end when you have the angle between the sun and the moon is exactly to 0 degrees in the center. And as the orbits are propagating, when that angle increases by 12 degrees, from there to then is Prathama or Pratipattithi, then Dvitiya, then Tritiya, then Chaturthi, and so on and so forth. Next, we have Vara and or Vasara. This is something we're all very familiar with, the 7 days of the week. Ravi, Soma, Mangala, Buddha, Guru, Shukra, and Shani. Next is Nakshatra, which I'll talk about on the next slide. Next one is Yoga. So the way yoga is measured is kind of like a similar to Tithi, but not quite the same. So in Tithi, you have the Earth, Sun, and Earth, Moon angle, and you're subtracting them. You're looking at the difference. For yoga, you're adding the 2 angles that you measure. And so every 13 degrees and 20 arc minutes, it will change. The yoga will change. There's 27 yogas. And so 13 and 1/3 degrees times 27 will again give you the full 360. And then Karana is half a tithi. So it's a 60.
I can also just ask this out loud if that's easier. So I'm curious to know, so you mentioned the angles measured from, I suppose, a location on the surface of the Earth, right? So I'm curious to know, like, what is a good way to think about the area where this would be like the same?
Right. So I think I know where you're coming from. Sometimes when there's a celebration, right, Ramanavami or something, Ratha Saptami today. In India, it might be a different day than in the America, and then some people like, which one do you celebrate? So the way it's done is the following. A tithi is a celestial phenomena. Its start and end occur regardless of where you are on Earth. It doesn't matter. The start and end are at exact times because it's a celestial phenomena. But when we celebrate things, we map it from the lunar day to our solar day, because for us, we're on based off the Earth's rotation about its axis. So how do you do that mapping from Tithi to solar day or Horatra? So the way it's done is that, so one of the most common conventions is that the solar day for us starts at sunrise to the next sunrise. So it's not midnight to midnight. There's also a midnight to midnight convention, but for the most part, sunrise to sunrise. And so whatever tithi is prevailing at the time of sunrise is what you apply for the rest of that day. And so because of that, sometimes what will happen is that in India, the tithi will fall on the quote unquote the next day. And then for us, it'll be the previous day. So it is incorrect to celebrate it according to India's time when you're in America. So this is a very common misconception. You need to celebrate it whenever it applies for you. So the tithi itself is a celestial phenomenon. Its time is fixed, but when you map it to the solar day, it depends on whenever your local sunrise is. So it is with respect to your local sunrise, whichever tithi is prevailing at your sunrise time.
That's great. Thank you. Yeah, that's helpful to know.
Okay, so yoga and then karana, which is half a tithi. So just 6 degrees of those separations.
Mother, I think we have also some other questions in the chat.
Okay, let's see.
I can also ask them. I was
Go for it.
Yeah, so one of them was like the Varas have their names. So is there an like a basis for like having those days? Like Ravi Vara Sun, Soma, is there a basis for the days as such?
Yes, there is. So you'll get to that when we talk about the grahas, navagrahas. And so I'll connect it back, but of the navagrahas, there's 9. 2 of them are not actual physical bodies. So the rest of them are the 7 that are, and those are the names of the vasaras or the varas.
And on that, I mean, it has a repetition in 7 days, so there is some basis to that. And you'll
There
talk
is
about.
some basis to that, right?
Okay.
Yeah.
And there was one point that written on a previous slide that said, what was that? Hora, it said in the bracket that it is for specific people and not for the collective. What do you mean by that?
So for example, you go check your jataka or you do a prashna of things, right? That's for you specifically. The next person over will have a different one, right? So there are certain prediction things that are there that are specified for you based off your situation. There's some that are general for the samaja that can be specific. That's what the difference is.
Okay, thank you.
Okay. Any other questions? Okay.
The topic of festival celebration, you just said, so we're supposed to celebrate Diwali when it's the daytime here, even if it's not the exact same tithi in India, right? Could you just elaborate that?
Sure. So, for example, with Deepavali, right? The tithi starts and stops at a very specific time that you can look up on a Panchanga or wherever, or compute it yourself, right? And so that start and stop time is the same regardless of whether you're in India or in the US. But your local sunrise is different in India versus somewhere here in the US, right? And so when that tithi is prevailing and it is your local sunrise, that's the day that you celebrate it. And so oftentimes what will happen is that they will be on consecutive days because India is on the other side of the world. There's that 11 and a half hours or 10 and a half hour difference that you'll see. And so what needs to be done is you check your local sunrise, and whatever tithi is prevailing at the time of your local sunrise is the day that you'll celebrate, whatever it is. Does that help?
Why the local sunrise again?
Because our days start at sunrise. It's sunrise.
Hmm. So it doesn't matter if the tithi starts in the middle of the day, that like Deepavali would if it started in the middle of the day would not be Deepavali for you still.
Right. So there's a few like exceptions to this. For example, the tithi for Deepavali, for example, if it were to start at like 4 a.m. and your sunrise is not until 6 a.m. and the tithi ends at like 4 p.m., just for example, right? Then for that day, Deepavali is that day for you because at the time of sunrise, the tithi was Amavasya for then. There's a situation that will sometimes occur that it is Chaturthi until say like 2 p.m. and then Amavasya until like 3 a.m. and then it's Pratama by the next day sunrise. So one day it was Chaturthi and the next day was Pratama. You just skipped Amavasya.
Skipped it.
So in those scenarios, you do it that evening.
You celebrate that evening.
Right. It's or that you can the evening of that day in which.
Okay.
And so for some things, it also depends on what the celebration is, right? Like Pradosha Kalam, it's supposed to be in the evening. So whichever evening has that. Or so like it just depends on exactly what it. Deepavali would be in the evening because that's the nature of that festival. So there are a few exceptions that have to be accounted for like that.
Very interesting, Daniel.
Yeah, so
Okay.
just to confirm. So the conflict is between the fact that the lunar day and the solar day are not the same. And so this is a reconciliation of trying to make sure that we align with.
Right, exactly. It's a mapping from lunar to solar day because they're not exactly the same. Okay, next. Nakshatra and Graha. What are these? There's often a lot of misconceptions about them. So nakshatra refers to 27 asterisms. You can basically think of it as like a constellation that are spaced out around Earth's ecliptic. So what does that even mean? So we know the Earth orbits the sun. All two-body orbits are planar. They take the form of a conic section, a circle or an ellipse or a parabola or hyperbola. For our case, that are closed orbits, it's an ellipse or a circle, right? They form a 2D plane in 3D space, and that plane can be oriented in whichever way. So along that plane, from the perspective of Earth, if you look out to the stars, you'll see certain stars spread out, around the sky along that plane. So that plane is called the ecliptic plane. And so 27 different stars patterns that are spread out around, the full 360 degrees from our perspective, those have been given the name of nakshatra, those 27. They're roughly spread apart around 13 and change degrees, 13 degrees and 20 arc minutes. And so again, you get a full 360 by that. So those are what nakshatras are. Each one has 4 padas. And so 4 times 27 is 108. So 108 shows up. There's a lot of importance to that number in Sanatana Dharma. We can make some connections later on if we have some time. But 27 nakshatras, 4 padas each, 108 groups of them. And so an analogy that you can use to understand that is that these nakshatras are numbers on a clock, and then the hand of the moon that rotates, and whichever one the moon is in front of is, the nakshatra at the time. One definition given is naksharatiti nakshatraha. That which does not decay or that which does not move is a nakshatra. That is, The stars are relatively fixed. They do change over the course of like thousands of years of their positions, but for the time scales that we usually care about, they are generally fixed with respect to each other in the night sky. The celestial spheres are generally regarded as fixed. And so that's why they're called nakshatra. They're things that do not move. Sthira. Graha, on the other hand, usually refers to what we call the navagrahas that we talked about earlier. There are others, but these are the ones that are the most important. An important thing to note is graha does not translate to planet, as we usually use the term. That's a very big misconception that comes up. One definition of graha that's given is grunhati bhaniti graha, that which quote unquote grabs and catches other stars or other sources of light. Basically, it means from our perspective on Earth, that which moves with respect to everything else, the celestial background, is called a graha. That is why we have Surya and Chandra, the sun and the moon, are called grahas. They're not planets. No one said they're planets. They're grahas because from our perspective, they move with respect to the celestial sphere. All the other stars appear fixed with respect to each other. But the moon and the sun and all the other planets, like Mercury, Venus, etc., move with respect to the celestial background. And that is why they're called grahas. It does not mean planet as we usually use that. A fun fact is that the English word planet comes from a Greek origin. And in Greek, the word planet means the wanderer. So in Greek, it was fine. In Samskritam, it's fine. It's just in English that we messed up in the translation. And so that's why Surya is a graha and not a nakshatra, even though nakshatras are stars. And yes, we know the sun is a star, but it's from our perspective, it moves and the other stars don't. That's all that is. Okay, so to the question earlier about the 7 days of the week and then why there's 9 navagrahas and 7 days, 2 of them are not actual planets or physical bodies. We have, let me go back. So Surya, Chandra, Mangala, Buddha, Brihaspati, Shukra, Shani, Rahu, and Ketu. So Sun, Moon, Mars, Mercury, Jupiter, Venus, Saturn, and then 2 are called Rahu and Ketu. What are these? They're not physical entities, but they're a geometric construct that shows up. So we talked about how 2-body motion is planar, right? You have the Earth's movement around the sun, it forms a plane. Now the moon's orbit around the Earth is also planar, but it's not the same plane. There's an inclination to it, about a 5-degree inclination. And so when you have 2 planes, the intersection of 2 planes is a line. That line is called a nodal line. And because of that inclination, so this description is showing from the Earth's perspective. Obviously, the Earth goes around the sun, not the other way around. But from our perspective, this is what it looks like in the night sky. So what that means is that as the moon is orbiting the Earth, there's a time in which the moon's position is quote unquote below the Earth's ecliptic plane and it'll pass above. And then there's this time on the other side where it'll go from above to below. When it goes from below to above, it's called the ascending node. And from the other side, it's called the descending node. The ascending node is Rahu and the descending node is Ketu. That's all they are. They are just physical, they're geometric properties due to the orbits. And there's a Puranic story that everyone knows of how, Rahu and Ketu was like a snake that got cut in half and all of that. The quote unquote snake was just a metaphorical representation of this nodal line. So that's all that is. Okay, 27 nakshatras. So this diagram here is a top-down, quote unquote, top-down view of the solar system. And along that ecliptic plane, you'll see a bunch of stars. And there are 27 of these nakshatras that are spaced about. The names are listed here. And we'll come back to this in just a moment. But there's also rashis. And so it's along the same ecliptic plane that, certain groups of these stars, so that are also grouped together in a different way, for example. And so there's 12 of these rashis, and we'll see that there's a similarity with the Greek tradition that there's a 1-to-1 mapping and what their the names that the Greeks have given to these rashis and what we have given to them. And so again, they're just split about, and there's 12 of these rashis. There's a comment I see a comment that assumes the sun moves around the Earth. No, we do not assume the sun moves around the Earth. There's a concept of reference frames that show up in engineering or any astronomy. You pick your reference frame and you can express things with respect to that. Since we are on the surface of the Earth, we choose Earth as our reference frame. For example, if we're working with a satellite, an Earth-observing satellite, we will express its position and everything in an Earth-centered reference frame because that's what matters and it cares to us. You can do it in a sun-centric reference frame, but it's not really useful for your purposes. And so we're not assuming the sun moves around the Earth. It is just a reference frame that we choose for our convenience. And I can show a simulation later of how this actually works, but we can get back to that. Okay, so 27 nakshatras and 12 rashis. And so how are these connected? So there's a concept of sankramanam. So here you see the sun, you see the Earth, and then it's maybe a little hard to see, but there's a moon that's going around the sun, around the Earth. This plane is the ecliptic plane, and then you have 27 nakshatras with 4 padas each, so there's 108. And if you take the 108 and you divide it by 9, you'll get 12, which are the 12 rashis. And so these red groupings are the different rashis, and each of the vertical lines are those 108 of the padas of all the nakshatras. From the perspective of Earth, whichever nakshatra that the moon is in front of will be that nakshatra. And as you go from one to the next, it's called a sankramanam. From the perspective of Earth, whichever rashi the sun is in front of, it's that rashi. And if you go from one rashi to the next, that's a Surya sankramanam, or sankranti is the other word that's often used for that. And so this is a concept that will come back later. Basically, from your perspective on Earth as your reference frame, where is the sun appearing in the sky and where is the moon appearing in the sky with respect to the celestial background? That will define what nakshatra or what rashi that you're in. Nakshatra for the moon, rashi for the sun. Okay. Now we'll talk about masa, the months. So there's many systems that are used. One is the Chandramana, or the lunar/lunisolar month. There's also Sauramana, solar month system. There's a nakshatra. There's many different ones. The one we'll perhaps see most commonly is the Chandramana one. So as we mentioned earlier, that the month starts on the first day after the new moon. So Amavasya is the last day, and then Prathama is the first day of the month. There's a Shukla Paksha, where you have the 14 tithis of the waxing fortnight, and then Krishna Paksha, which is the 14 tithis of the waning period of the moon. And then you have Amavasya and Purnima in between. There are the 12 months, the names of the lunar months: Chaitra, Vaishakha, Jyeshta, Ashadha, Shravana, Bhadrapada, Ashvayuja, Kartika, Margashirsha, Pushya, Magha, and Phalguna. So these are the names that we're all familiar with. And this is the lunisolar month system. Now, if you're in the Sauramana system, it is based off the Rashi, is the way that the months are named. And there's a naming convention for these months. They're not just arbitrary names. Depending on which rashi or which nakshatra the moon is in front of, that influences the name of the month. So the way that the months are named are the following. We said that the months are bookended by Amavasya, and in the middle of the month is Purnima. So on the day of the full moon, on the day of Purnima, whichever nakshatra the moon is in front of will determine the name of that month. So for example, if the moon on Purnima day is in front of Chitra or Swati nakshatra, it's Chaitra Masa, Chitra to Chaitra. If it's in front of Vishakha or Anuradha nakshatra, it's Vaishakha Masa, and so on and so forth. Jyeshta or Mula is Jyeshta Masa, and so on and so forth. So here you can see the color mapping of how the nakshatras, whichever nakshatra the moon is in front of, will influence the name of the month that you're in. Okay. Next, there is a concept of Malamasa. This comes up because due to a concept we had discussed earlier of how the lunar day and the solar day are not exactly aligned, and so it is a way to it's an algorithmic and systematic way to realign the lunar calendar and the solar calendars. because they slowly drift over time. And the way it's done is through two means. One's called Adhika Masa and the other is Kshaya Masa. Together they're called Malamasas. Adhika Masa occurs in the following. When you have a lunar month that does not have a Surya Sankramana. So now you have to consider both the lunar system and the solar version together here. So normally, for the most part, each lunar month has a Surya Sankramana that happens in the middle of it. So for example, we have Makara Sankranti that had just happened about 10 or so days ago, right? And so then it was Pushyamasa in the lunar system. And then we had the Makara Sankramanam that happened in the middle of that. So for the most part, that will happen like that. It will align like that. Occasionally, what will happen is that you'll have a lunar month that starts after one Sankramana, but ends before the next Sankramana. That is, the 30 lunar tithis in time are shorter than 30 solar days, essentially is what happens. In such a case, it's called an Adhika Masa. It's like an Adhika extra, one bonus month. And for example, if there was an Adhika Masa that it was supposed to be Chaitra Masa, but then there was an Adhika Masa. Following that Adhika Masa is then the true Chaitra Masa. There's Chaitra Adhika Masa and then the true Chaitra Masa in that context. And they're said to be very auspicious for any religious purposes because they're a very special celestial occurrence that happens. And then there's called Kshaya Masas, which are much rarer. I think the last one was about like 40 years ago, and the next one will be in 100 years or so. So these are much more rare. What happens for a Kshaya Masa is that you have a lunar month that is longer than 30 solar days, and it actually spans two Sankramanas. You have two consecutive Sankramanas within the same lunar month is when that happens. And because of the way it works out, you'll always have an Adhika Masa before and after a Kshaya Masa, because that Kshaya Masa covered two Sankramanas. And so when these occur, there's an algorithm to computing when these will occur. It's a systematic way for the calendars to realign and correct themselves. Okay. Next, so as we're going up from small Tithi to Vara to Masa to next is seasons, the Rutu. So the Rutu is, there's 6 of them that we know, Vasanta, Grishma, Varsha, Sharat, Hemant, and Shishira. Each one is given 2 lunar months, and the Gregorian months that they approximately correspond to are on the right-hand column here. Okay, so there's a question in the chat. Isn't the lunar month always 29 and change days? Is it ever longer? How is it ever longer than solar month? And so when we talk about the length of the month, we have to be careful whether we're talking about it in terms of time or what are you measuring against. If you remember, the Tithi system, the lunar month in the Hindu calendar, it's not based off fixed time. It's based off fixed angle. And so based on the orbit, sometimes the time it takes to span that fixed angle can be shorter or longer, just depending on where you are in the elliptical orbits. And so it is fixed in terms of angle, but it's not fixed in terms of time.
Hello, it protects you from
Does that make sense? Okay. Is the distribution, is Earth's computer, I am using my reference frame to view my computer, right? Everything's with respect to the observer. If the distribution of Rashis with respect to the reference frame of Earth, cylindrical or elliptical, it doesn't matter. The stars are so far away that it's just what's against the background sky. So it won't make a difference whether you're considering it to be cylindrical or elliptical orbit, because the stars are not in orbit. They are basically infinity far away for our purposes. Okay, next. Ayana. So we went from Rutus to the next higher time unit, the ayana, the solar halves of the year. So the year is divided into two parts, which is Uttarayana and Dakshinayana, which is the quote-unquote northward or southward travel of the sun on the horizon. And so a common story that we all have heard is in the Mahabharata, Bhishma Pitamaha waited until Uttarayana before he chose to pass away. So Uttarayana is from the winter solstice to the summer solstice, so December 21st-ish to June 21st-ish. Dakshinayana is from the summer solstice to the winter solstice. Makara Sankranti is not Uttarayana. It's a common misconception. It used to be at some point in time long ago. A Sankramana, as we said, is when the sun goes from one Rashi to the next Rashi from the perspective of Earth. Uttarayana is when Earth's axis, which has a tilt of 23 something degrees, that axis, when it's pointed towards or away from the sun, as you see in this diagram here on the right. Earth's axis, even it is tilted and it precesses. For example, if you spin a top, you'll see this kind of movement happen. It's called precession. So the same thing happens with Earth's axis. And so when the solstice occurs, changes over the years. It will slowly change based off the precession of Earth. And so at some point in the past, Makara Sankranti may have coincided with Uttarayana when we started saying that, but it is no longer the case today. They are two different things. They occur at two different times. Makara Sankramanam is January 14th or 15th. Uttarayana starts on December 20th or 21st, depending on exactly where the orbits are. Okay, next, the year, Samvatsara or Vatsara. So there's many different systems and that are used for a reference epoch that you pick. So whenever you measure time, you need to have a reference start point, right? For example, in the Western system, we'll choose 0 CE as our reference point, and we measure, CE or BCE before CE. The reference point, one reference point that is used in Jyotiṣa is the start of Kali Yuga for us, which maps to the Gregorian system of about 3102 BCE, or about 5120 something years ago. So the current year per that system, we will say is 5126. It measures the number of years that have fully elapsed and not the current ordinal year number. And so if you take 5126 minus 3102, you'll get 2024. Now the question will arise, if we said it's a number of years elapsed and not the current ordinal year, instead of 2026, you should get 2025 when you do the subtraction. Why are we getting 2024? Any ideas?
Something to do with 0?
Nope.
BCE, I mean.
No, not that.
The year is between Chaitra and not from January.
There we go. Yes, exactly. It's from Chaitra to Chaitra. So once we hit Chaitra, then it'll be 2025.
That makes sense. Okay.
Because it's not January to January. Next. So the names, so all of these years we have a cycle of 60-year names. So they're given a name. For example, the current one is Vishwava. So before that it was Krodhi, then Shobhakrit, before that was Shubhakrit, before that was Plava, and so on and so forth. There are 60-year name cycles that repeat. Now, why 60? There's also an interesting thing there. If we have time at the end, we can come back to it. Might be running a little low on time. But there's a celestial phenomenon that also influences why there's 60. And so the New Year day would be, in the Chandramana system, it'd be Chaitra Masa, Shukla Paksha Prathama Tithi, which we call as Yugadi or Ugadi, depending on where you're from, or Gudi Padava, or there's many other names given to that. In the Sauramana system, it's the Mesha Sankramanam, Mesha Rashi. And so that will be about April 14th or 15th. So both are around the springtime, which we celebrate as the start of the year. Now, I will note that there are a few traditions in Bharat in which it is not one of these two. Notably, the Gujarati tradition in which it's after Deepavali, the Amavasya after the day after Amavasya of Deepavali is when they celebrate their new year. So there are a few different systems, but for the most part, it's either the Chandramana Yugadi or the Sauramana Mesha Sankramanam that is treated as the new year. Yes.
A quick question. So that the Kali Yuga dating that you have started with 3000 BC, is there like a source that strictly mentions that, or is it more based on an estimate?
So the way that was computed is the following.
Just a quick, just to follow up, my basis of that question was, I mean, there has been a lot of talk about when did Mahabharata happen
Right.
and like, the Dwapar.
Right.
So yeah.
Yeah,
So
I
the
had
way
that
it was
question.
dated is the following. In the Mahabharata, there are many celestial phenomena that are recorded. For example, when a certain quasar or a certain celestial phenomena happens, and you notice this, or there's a certain comet that comes. And so folks have looked through all of that and basically tried to fit down the date. Okay, when did these celestial phenomena that were recorded in the Mahabharata, when did they actually happen in our Gregorian system? And based off the intersection of all of these phenomena, they have come down to the idea like, okay, this is most likely when Kali Yuga has started. So it is an estimate. It is hard. It is difficult with anything that's historical to nail down exactly, but that is our best guess, best estimate of when Kali Yuga started, based off those celestial phenomena that were recorded in Mahabharata and other Puranas. Okay. Next. Okay, so let's take a break here, and if there's any other questions before we move on.
I have a curiosity question. So you mentioned that because of the precision of the orbit, it's possible that sometime back there was an overlap between Sankranti and Uttarayanam. So I'm
Right.
curious to know, like, is there a way to simulate that as well to get an estimate of how far back that could have been?
Yes, there is a way you can do that.
Like that can like AstroPi or something do it? I don't
Yeah,
know.
you should be able to do that if you can model. The thing is with precession, the precession itself is not constant. The precession rate also changes over time. So you need to have a good example of that. But yes, you can, if you were to just pick it as, if you were to just keep it as a constant rate of precession, and you just go back in time, you should be able to do that.
Cool, thanks.
Okay. Alrighty.
So if we trace it back to the Mahabharata times, when Bhishma actually waited for the Uttarayana before he let go of his body, right? So
Correct.
would it map to the Makar Sankranti at that point in time, or it doesn't matter?
It doesn't matter. Makara Sankranti has nothing to do with Uttarayana. Remember, they're
Okay,
computed in two different ways.
sure.
Uttarayana's Earth's axis is pointed towards or away from the sun is the solstices. Sankramanam is from the perspective of Earth, where is the sun with respect to the background stars. So they're two independent computations that just happen to overlap at one point in time.
Thank you.
Okay. So some relevance to practices that we may see and come across. The most of all of these, different units of time and systems that we have talked about. The most common one we'll see is the puja sankalpa. You go to a devalaya, a temple, and then the pujari will take your gotra namas and you'll do your sankalpa. Or if you do any nitya anushtana, you will do this daily as well. And this also kind of ties into the philosophy that we talked about last time. We talked about how each action, when you do it, the time and place matters. And in the sankalpa, you are very explicitly acknowledging to the universe of where you're doing that action, when you are doing that action, who is doing that action, why you're doing the action, how you're doing it, and what the action that you're actually doing is. And so when you look at the sankalpa, if you actually listen to it, all of these are specified. For example, Asya Shri Mahavishnoragnaya Pravartamanasya Adya Brahmanaha Dvitiya Parardhe Shvetavaraha Kalpe Vaivasvatamanvantare Ashtavimshati Kal Yuge Prathame Pade. So sometimes we're mentioned there. And here in the US, Kraunchadvipe Ramanaka Varshe Aindra Khande Uttara America Deshe, for me, Texas Rajye, Houston Nagare. And then you'll talk about who the Yajamana. For example, Ramachandra might say, Shriman Vasishtha Gotrodbhavasya Ramachandra Namadheyasya Sakutumbasya. The purpose, why are you doing the puja? Dharmartha Kama Moksha Purushartha Phalasiddhyartham, for example. How are you doing it? Purusha Sukta Vidhanena. What puja are you doing? Shorashopachara Pujan Karishye. So all of these things are mentioned in the Sankalpa of who, what, where, when, why, and how. And so it is an acknowledgement of these that you're embarking on whatever action you're doing in that sankalpa. So this is where you'll see all of these different things mentioned. And you'll also see, the exact Shri Vishwa Vasunama Samvatsare Uttarayane Shishira Rito Maghamase Shukla Pakshe Ratha Saptami Shubhatito Ravivasare Yuktayam, and so on, right? So all of these things are recorded in the Sankalpa. So this is where we will really see all of this. You see it on a daily basis, but it helps when you slow down and actually listen and understand where all of these are coming from, and all the celestial mathematics and orbit tracking that has to happen in the background for you to be able to do that. The other thing is that all of the festivals that we celebrate are based off these calendar systems, either the Chandramana or the Sauramana systems, right? For example, Yugadi we talked about, Ramanavami, Chaitra Shukla Navami Tithi, Deepavali is the Amavasya after Ashwayuja Masa, Mahashivratri is coming up later this Magha Masa, right? And traditionally, we celebrate our birthdays as per a tithi or nakshatra and not our Gregorian date. And so that is that's our tradition. And so for those of us that live in the US, we often have this practice of having 2 birthdays every year. You celebrate your date one and your tithi one, or your nakshatra one, 3 birthdays even. So there's that. So I'm going to do the following since we have a little bit of time. I want to show how some of these things are actually computed, and where you get that from. So
I'm just going to interject here, Mahodaya, for a bit. The form in the form link in the chat, if you can all please fill that out, just for us to get an idea of who all are attending this, that would be great. I'm just sending it right now. Dhanyawadaha.
okay. Okay. So whenever you go to whatever Panchang website that you like and you're trying to understand how are all of these things being computed. For example, my Panchang, you'll see here, it says based on NASA JPL's data for accuracy, and you'll see based off NASA's JPL ephemeris. So what does that actually mean? So we're actually going to walk through that and how that works right now. So let me pull up some code. I can just walk through exactly how some of these things actually work. So the ephemeris system, it's called SPICE, is the name of the system, and SPICE kernels are specific files that contain all of these data in them. And so I threw together a quick script that uses the SPICE information to how you can actually compute all of these different things. This file is for tithis. So some of the things here I'm doing is the following. I'm loading in. You can see my screen, right? Okay, cool.
Yes, we can.
Yeah, so I'm loading in a planetary SPICE kernel. This tells you the position of the Earth, Moon, Sun, all the planets for the time period that we care about, accounting for leap seconds. And here, in this case, I've chosen some date. This is a date of the last total solar eclipse that happened 2 years ago in the US. And using SPICE, I will query for the following. I want the position of the moon at a specific time in the J2000 reference frame, accounting for light time and stellar aberration corrections with respect to the Earth. And so even though the reference body is the Earth, that doesn't mean we're not saying the moon or the sun orbits the Earth. You need to be very careful and understanding that you choose your reference frame based on what you want to compute. It is just a reference frame. And so we choose our reference frame to be Earth in this function. And then also for the moon and for the sun. So I get the position and velocity for the moon and the sun. C for Chandra, S for Surya here. I extract the positions from them. I turn them into unit vectors, so directions instead of the actual length of it. I then compute the relative angle between the Earth and the sun here. And then you can plot it over time. And so I pre-recorded this because it'll be a little bit slow to do it live, but here. So in this simulation, this is just a recording of the code I had just shown. You have the Earth in the center because that was a reference frame that we chose. we have the sun and we have the moon, Chandra and Surya, and you see them moving, both of them are moving, right? As the angle between the Earth and the sun increases by 12 degrees, you'll see the Tithi change from now Chaturthi to 48 to Panchami. And then at 60, it'll go to Shashti. And so on and so forth. And so the important thing to keep in mind is that both the sun and the moon are moving. And so it's the relative angle between them as you're orbiting. And again, this is not saying that the moon and the sun orbit the Earth. This is just a reference frame that we're choosing for our convenience because that is the perspective that we have here on Earth. Okay. Next, we can talk about Rahu and Ketu. So how do you compute when and where an eclipse occurs and where Rahu and Ketu would be? How do you predict that? So it's the same date of the eclipse. Again, getting this position of the sun and the moon. Get the positions and then get the unit vectors from them. And then here, I have a quick computation of computing where the nodal points are. Which direction is Rahu and Ketu being computed here? And then plotting. And so here, again, Bhumi, Earth in the center, and sun and the moon as you're propagating forward. And so as we go forward in time until we get to April 8th, that's when the eclipse had occurred. And so you'll see that show up. But one more thing I want to note here is, as you can see, there is an inclination. There is the plane that the sun is making and the plane that the moon is making are about 5 degrees separated in space. And you can see that in the simulation. And there you go. And so at this point, you see them all three aligned, and that's when you have the eclipse. And now one thing to note, here you see the purple arrow, that is Rahu, and the other one, the green one, is Ketu. That's the nodal point, so where the orbits intersect. Now, one thing to note is that you see the sun and moon aren't exactly right on that point. They're a little bit after. It's just due to the sizes and the distances of all of these celestial bodies, they don't actually have to be exactly on. As long as it's close enough, you'll still have an eclipse. And so for a different eclipse, it might be a little bit closer, it might be a little bit farther. It just depends on the exact geometries. Now, this is not a 2-scale plot because the Earth, the sun is much further away than the moon is from all of these. So this is all just unit vectors, so you can just see relatively what's happening. But because the sun is so far away and it's so big, it doesn't have to be exactly on the nodal line to get an eclipse, but just for sake of simulation, that's what we see here. Okay, and so that's how eclipses were predicted, and you could compute that. Okay, I think we're at time, and so I will stop sharing, and if anyone has any questions, we can take them.
Namaste. I had a quick question.
Mhm.
And so can you talk a little bit about when there are 2 tithis in one day?
Yeah, I can. So let's say the tithi, we'll take Prathama Tithi. It starts at, say, 2 a.m., your local time. It then ends, it starts at 2 a.m. Your sunrise is at, say, 6 a.m. So at sunrise, it is Prathama Tithi for you. Prathama Tithi, let's say, ends at 2 p.m. And so Dvitiya starts at 2 p.m. And then Dvitiya goes on to, say, 2 a.m. And then the next day would be Tritiya, right? And so you skipped, somehow there's no solar day in which sunrise overlaps with Dvitiya Tithi. Dvitiya was in between, quote unquote, 2 days, if that makes sense. So Dvitiya was only during the afternoon and evening and nighttime. And so if there is something that you needed to celebrate on Dvitiya, you would do it that evening. There's a few different conventions and traditions, but that's one of them, that you'll just celebrate it that evening instead, because there was no full day that was associated with Dvitiya, because the first day would be Prathama, and the next one ended up being Tritiya, just for example.
I see. Thank you. That makes sense. And is it more common in a certain time of year, or is there a way to predict that that's going to happen?
Yes. There's not really, it's not really that's more common or less common. It just depends on the orbits. But you can predict when that happens, and I can show you that real quick. You don't have to code it yourself. There's tools out there that do it for you. But here, let me share my screen. So here I just went to a Panchang website. Here you'll see sunrise for me local was, or I guess it's set to Delhi, but 7 a.m. and change. You'll see Ashtami ends at 9 p.m. and then Navami starts next, right? And so you can use these kind of things to see exactly when Ashtami starts. Ashtami ends here and then Navami starts. And so basically you can just go to any of these tools and it'll tell you when each of the tithis start and end or anything else that you're looking for. So just go to the tool and it'll tell you. And the way that they compute it is very similar to what I had shown you. They use the SPICE system to query for the positions. Now, this is the modern way of doing the computations because we have much better technology and tracking of celestial bodies. Now, the ancients, the way they did it, it's quite remarkable of being able to do that way back when. And that's a whole different topic in and of itself of how we would be able to actually do these computations way back in the day.
Thank you so much.
Namaste, Mahodaya. Generally, the tithis, they'll be roughly 24 hours, right? It may not be exactly 24, slightly more than 24 in some cases, and slightly 2-3 hours less than 24 hours also in some cases, but never like 12 hours, right?
It can be. Maybe not as short as 12 hours, but they can go pretty short. Like I've like 17, 16 hours that can happen too.
Okay.
The reason why that can happen is the following. Because the Earth's orbit around the sun and the moon's orbit around the Earth are both ellipses, right? They're elliptical orbits. If you go to Kepler's laws of motion, right, we'll see that the closer you are to your central body, the faster you will move. And so when the moon is near its periapsis of its orbit, that is its closest point to Earth, it'll move much faster. That is, the angle will increase much faster than it is when it's further away. And so just depending on how the orbits line up, you can have the moon moving much faster if it's closer to its periapsis, and therefore the tithi will go faster.
Okay. Thanks for that explanation.
Is there a high level is there a high level way we could understand the 7 days, like the thing that you mentioned, and you said that there were 2 geometrical concepts, right? In the Rahu Ketu. Is there a way we can understand right now like what is the basis? Like is that the case that the Surya and Chandra are visible geometrically at some point when it's a Monday or Tuesday, like that? And why does it repeat every 7 days?
So of all the celestial bodies in our solar system, these 7 are the ones that are visible to the naked eye, right? The other ones, up to Saturn, you can see with the naked eye. Uranus and Neptune and any of the other bodies you cannot see. And so those were the ones taken to be the most important because the ones that you could see, right? And of the 9, Navagrahas 2 are geometrical constructs, and 7 of them are physical bodies. And so those were taken to be the 7 days a week. Now, there's an interesting history that's a little bit hard to trace down because you see that the Greeks also had the same system, right? And there's a lot of interchange between the Greeks and the Hindus of ancient past. Even Mahabharata, they're mentioned. They're called the Yavanas in Samskrita. So Mahabharata, there's a famous character of Kala Yavana, the dark Yavana. He came to Bharat and then got sunburned. And so you'll see mentions of a lot of interactions with the Greeks in Śāstra. And so at some point, there was some interchange that happened that the Greeks also had the same system. Now, I personally do not know whether it started in Bharat and went to the Greeks, or it started with the Greeks and came to us. It's really hard to know because there's a lot of gaps in the available text that we have today. We have really old text, for example, Vedāṅga Jyotiṣa, which is the oldest, I guess, the one that we have now. And then there's Surya Siddhanta that's just very old, but we have it in a current form that we don't really know what changes have necessarily happened over the years. And then there's a huge gap between, Vedāṅga Jyotiṣa to the time of like Aryabhata and Brahmagupta and all of them. And so there's gaps in the history that we don't have. It was recorded likely at some point, but those texts have been lost. There's those stories of, the burning of Nalanda and Takshashila. A lot of our libraries were burned down by invaders. And so we have lost a lot of the records. And so for some of these things, it's hard to know and figure out when that interchange happened or where it came from, just because there's loss. So there's a lot of people that do research on this. I'm not personally have not looked into very much. So there's others that may be able to answer that better.
Sure, thank you. I was just curious about the periodicity. Like, I understand the 14 days periodicity, the month periodicity, but is there a significance to the 7 days periodicity? That's what I was more curious about. Or is it just half of 14? Is that it? Or that's
I do not know.
okay. Gotcha. Thank you.
Mahodaya, I have a question. So those of us who are interested in Sanskritam and are learning a little bit, do you have any suggested starting points to like know more about these aspects of Jyotisha, apart from the sources you mentioned right now? Yeah.
Right. It's so it's a little hard. The best thing with anything with Shastra is to learn from a guru, better than trying to pick it up and learn it yourself. Everything that I've shown today is a product of what I've been taught by acharyas or that has been passed down by achara over time, right? And so, or things that I've pieced together. I have a background in the Western sciences in this, right? And so when I see these connections, like, oh yeah, this is the same thing, right? So that is the content of here came from these three sources, from acharyas, from acharya, and from my Western training in this. So yes, you can find translations and things of like Aryabhata's and other texts or Vedāṅga Jyotiṣa and stuff, but best thing is to go find a guru, or at the very least go find a YouTube video of an acharya teaching it. There's certainly some there. Actually, I can let me send one such one in the chat. It's in English and it's given pretty well. He's this acharya. He's a professor at the Chinmaya Vishwavidya Peetham, and has given some talks on it that I think would be a good introduction. Let me find that link and send in the chat. How are tithis computed in olden days with the computers and things like that? So everything in the end is just based off angles, relative angles in space, right? Where something with respect to something else. And so there were old instruments that you'd have to use to measure angles. For example, if you're trying to measure the angle of the sun, you'd use a sundial, right? You look at the shadow projected of the sun on the earth. And so that's a whole different historical study in trying to understand the different instruments and mathematical techniques that they used to use back in the day. Next. Do we know how roughly long Kali Yuga will last? Yes, it's 432,000 years is the length that's given in Shastra for Kali Yuga. And then Dvapara Yuga is twice that length, Treta is 3 times, and then Satya is 4 times that length.
So we have the Eastern and Western system, right? One uses Ayanamsa and the other one doesn't use any Ayanamsa. And Sayana and Nirayana, they say, right? And even the system that uses Ayanamsa, there are different Ayanamsas, like Chitrapaksha. And then there was one by Krishnamurti, K.S. Krishnamurti, right? Krishnamurti Ayanamsa. And then there is one by Raman, B.V. Raman Ayanamsa. So when we have all this, is there any conclusion, at present, like which is, most accurate system?
So your accuracy depends on how well you can measure and how well you can model, right? And so the modeling that we have is through SPICE. That is the gold standard that exists today, based off this tracking social bodies and all of that. That is the best because everything depends on how well you can measure things and how well you can model the physics. And so in terms of just tracking social bodies, that's why even all the Panchang websites today will use the NASA system, because that is the best that we have today. That is not to downplay what our Purvikas have done. Because in that time, without the technology that we have today, they were able to talk about time units down to the truti, like microseconds level, and being able to even talk about that, or even all the way up to the time of the day and the year of Brahma, right? That is quite amazing that they were even able to do any of this and to the level of precision that they were able to back then.
Okay. Thank you, Siddharth Mohdaya.
Any other questions while I pull up the link to this video?
Mahodaya, do you have a GitHub repo or something with some of these scripts which you are willing to share so that we
Do I
can?
have a what?
Do you have like a GitHub repository or some way of like sharing these scripts so that we can play around with
Oh,
them?
the code?
Yeah,
I don't, but yeah, I can put it together and send that out.
that'd be fun. Thank you.
Well, I want to
Here,
go back to the question of Ratha Saptami, because I had been told in some WhatsApp forward that it was because of Uttarayanam. You've clearly said that that's not the case. So I want to understand what is the significance of Ratha Saptami in that scenario and why we celebrate this.
Ratha Saptami is celebrated as Surya Jayanti. I mean, the Puranic tradition of Surya's Jayanti is celebrated as Ratha Saptami. Saptami, you can imagine why that number was given there. Visible light, if you put it through a prism, you'll see 7 primary colors that will come out of visible light. And so you'll see that depiction of Surya that's given of being riding a chariot with his charioteer being Aruna. And that's why, the color right at dawn is called Aruna, because Aruna is what you see first before Surya. It's the color of the red color of dawn. So it's a symbolic metaphorical representation. You'll see Surya's chariot being driven by like the reins of the chariot are, the 7 snakes, right? And so, the wave propagation of light, you'll see some of these concepts being put in as metaphors, and the 7 horses with the 7 primary colors of the visible light spectrum. So things like that you'll see.
Got it. Well, why today? Why is today an important day in the celestial calendar?
Because it's said in the Puranic tradition, it's said that it is a Jayanti, the quote unquote birthday of Surya. Any other questions?
Going back to the 3 divisions that you mentioned in the beginning, right? The Siddhanta, Samhita, and the Hora. Is it right to understand it in this way? Like if we take Siddhanta, we have Surya Siddhanta, for example, and there could be other Siddhantas also, right? And if we take Samhita, there was Brihat Samhita, right, of Varaha Mihira,
right? And
there could have been other Samhitas also.
Correct.
And Hora, we have the Brihat Parasara Hora, right? And that is a very authoritative one, Hora Shastra, and there may be other Hora Shastras.
Yes.
But is there anything, which is there one text, where all these 3 are, mentioned? Or if that is not the case, which is the most authoritative text for each one of these 3? Right? For Hora, which is like the main text.
Any of the texts for Samhitas and the Horas, the basis of Jyotiṣa is Siddhanta. It is the astronomy, timekeeping, the geometry, the math behind it, right? And so anything that will use that it'll show up in there. So Aryabhata's text or Varahamihira's will have Siddhanta in it because that is the basis for it, right? They're not like disjoint things in that sense. Based off these celestial positions and all this, based off what the physics predict, then those texts will do whatever prediction, saying like this tithi is auspicious for this purpose or this or that, things like that, right?
Okay. So you're saying the Siddhanta will be part of it, even if it is not exclusively about Siddhanta.
Right.
Okay. Thank you.
Any other questions or comments or anything else?
Astamode, maybe. Oh, go ahead.
Yes, Mona. Would you mind sharing the name of your Guruji and the tradition that you were trained in? Like, what
Tradition
was
is
your training, as in what kind of training that you underwent to know all of these things? Like, and how long was it? I mean, only if
So
you're comfortable sharing that.
I will decline sharing it because it's not about me, it's about the content that was shared. So, I mean, my acharyas, I'm from the Advaita Vedanta Sampradaya of Sringeri is what I follow. I've been trained by acharyas from that Sampradaya, but yeah.
Oh, this was fantastic. I can't thank you enough. I'm definitely not a Yuva by any stretch of the imagination, but I'm glad that the Yuva Bhaga is conducting programs like this. One, I think, burning question for a lot of us, I can imagine, is that we hear about yugas and the timescales being ridiculously large. And then if Rama is from the Treta Yuga and that's literally lakhs and lakhs of years before, does that kind of square with the astronomical observations in the Ramayana itself? And also, because of that, maybe there's a kind of related question is, I imagine these cosmic patterns repeat over time. So then there's a particular point of time when the exact same celestial position will repeat itself. So then how do they kind of account for that in making sure that we know the exact date and time?
That is absolutely correct. It's hard to find out exactly when because they do repeat themselves. So one of the techniques is you have multiple different kind of celestial phenomena, and you see when each of those, it'll happen periodically, but when do all of them align? And so even then, those intersections can also repeat. And so there's a lot of historical work that's being done on that has been done, it's being done on that. And again, it goes back to not having enough data because we've lost a lot of the history over time. But yeah, there are estimates, but it is a very hard thing to try to align up and try to figure out. And so I don't personally really know. I've not tried doing it myself, but
Just a comment. Thank you so much, Mahodaya. This was very, very helpful. Sometimes we really underestimate what we have in our hands, and I think you have very much concisely used today's technologies to really articulate these things pretty well and put forth. So, thank you so much for doing a great job on that.
And looks like from at least those of us who turned our videos on, we have people across the spectrum from kids to adults all like getting inspired. So it's really great that you put this together. Dhanyavada.
So yeah, Bahu Dhanyavadaha Mahodaya. I think the simplicity in which you explain such complex concepts kind of show us the hardcore legwork that you have done to learn it yourself. So thank you again for taking out your time for this two-part series. And Siddharth Mahodaya, he is a member of the SNYP group. SNYP stands for Samskritam Network of Young Professionals. So our goal for this group as a part of Yuva Vibhagaha is to have our own members lead these sessions like Siddharth Mahodaya has done, and then connect Samskritam to different topics. So for example, he used Jyotiṣa to connect it to Samskritam, and through that we got to learn very interesting shlokas. So sometimes we'll just meet up for the SNYP Milanams to do these simple Sampashanam with each other as well. It doesn't always have to be such a complex topic as well. And then, so if any of you are out there that would like to come forward and lead more topics like these, please reach out to us. Our next Melanam will be held maybe in another 4 to 6 weeks. And it's always good that we kind of like keep what we're learning and then build upon that. So Govind Mohadeya suggested in the chat that maybe we should do a quiz next meeting. So maybe we'll do that. We'll have like a Samskritam quiz on what Siddharth Mohadeya presented for us to kind of retain this information a little bit.
Fantastic idea.
Yeah. And also the form that I put in the chat, if you filled it out, then we'll send out, everybody's asking for the recording link. We'll use that contact information to send out the recording or the Samskritam shlokas and etc. So once again, thank you all for joining. I'll end this with the Mangala Shloka. Om Sarve Bhavantu Sukhinah Sarve Santu Niramayah Sarve Bhadrani Pashyantu Ma Kaschit Dukhabhag Bhavet. Om Shanti Shanti Shanti. धन्यवादः पुनः मिलामः.
धन्यवादाः.
धन्यवादः.
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 बहवः धन्यवादाः.
धन्यवादः.